So good afternoon everyone. Welcome to a lecture of the course on design and analysis of algorithms. So in today's lecture we shall, in the previous lecture we have understood the flow network and the concept of residual network, and today we shall continue from there. Using the concept of residual network, we will understand the concept of augmenting path, and then we will illustrate the augmenting path algorithm to maximize the flow along a flow network. Okay. The importance of residual network is to increase the amount of flow in a flow network. Okay. So I think because we are trying to consider a maximization problem, which is maximum flow in a network, right? Maximizing the flow in a network. So it's a maximization problem. And how can we maximize the flow? So the first concept is residual network, which will help us to increase the amount of flow along a path. Okay, so how can we do that? So let's take an example. Okay, so this is the original flow network given. Okay, so now just I'm again reading out uh, vertex S, that is the source, vertex T is the sink, this is vertex A, this is B, this is C, D and E. S to A 0 by 3, this is 1 by 1, B to C 1 by 5, A to C 0 by 3, and B to D 0 by 4, D to E 0 by 2, C to T 1 by 2, and E to T 0 by 3. And this is a flow network. Just tell me what will be the flow of this flow network denoted by mod of f. What is the value of mod f? That is the flow of the overall network.
1.
1. Okay. So this is, as per the definition, summation of all f u v for all v belongs to capital V. Okay, so let's say in this case it is S is the U, and we may have several vertices V. Okay, so that means it is equal to the sum of flow of S comma A and f of S comma B, and that is 0 plus 1 is equal to 1. That is the flow of the overall network, and eventually it is this is the net outgoing flow from the source, and it is equal to the net incoming flow towards the sink. That is, let's say VW, okay, for all V belongs to capital V. So here T is your W, okay. So then we may have several V's. Here C and E are the V's. So if you sum them up, you will get a flow of C comma T plus flow of E comma T, and that is 1 plus 0, again it is equal to 1. So it is satisfying the flow conservation principle. So flow of the overall network is ultimately 1. But the question is, can we increase the flow from source to sink? One of the algorithm is augmenting path algorithm or Ford-Farquharson algorithm. Or augmenting path algorithm. Okay. Now, before going into that, we must understand augmenting path. And augmenting path is based on the residual network. So let's construct the residual network of this flow network G. So first here, so please try to draw the residual network as fast as possible in your copy. I hope all of you are attending the class with paper pen. So there will be no there will be
backward हो
forward, huh?
yes sir error machine तो backward हो ना ए सर error machine
Right.
forward हो
So only forward path, forward edge, and its capacity will be mean capacity will be 3, but there will be no forward path. Hey, backward edge. Sorry, no backward edge. So should I? Okay, let me draw over here. S A B C D. Is it visible? D? Visible. T E. Okay. So only forward path edge with capacity 3. And then S to B, we will not have any forward edge, but we will have a backward edge with capacity 1. A to C, 3, B to C, both forward edge, backward edge. Forward is 4, backward is 1. B to D, only forward with 4. C to T, both forward and backward, 1 and 1. And D to E, only forward with 2, and E to T, only forward with 3. So this is the residual network GF, whereas this is G. Sorry, our vertex mone hobe. So this is G, and this is GF. ঠিক আছে, GF টা দেখে নাও মিলিয়ে। ঠিক আছে না?
yes sir ঠিক আছে
Right. So now in this GF residual network, from source towards the sink, we want to find out all the possible paths. Okay. So in this process, in this residual network, we can see that this is a path. Is it correct?
yes sir
And no other path we can find out, because from S we can have 2 edges only. One is S to A, another is S to B. So a path is possible along the edge S to A, but no path is possible along the edge S to B, because there is no forward edge from S to B. It is a backward edge from B to S. So you can't go from S to B. So
আচ্ছা
thereby
স্যার
you
আর
can't.
একটা পাস হবে না
হ্যাঁ
হ্যাঁ
স্যার
স্যার,
যেটা
সি
স্যার
এর থেকে
এস
বিতে
এ
গিয়ে
সি
Oh yes,
বি ডি ই টি ওটা
yeah. So we can find that. So
ইয়েস স্যার
I hope the figure is okay with you. You are able to understand the figure. Okay. So these are the two paths which we can find out. Okay. Both are paths from source to sink. Out of these paths are supposed to be increase the flow from source to sink. Okay. Now, out of these paths, I will select that path as an augmenting path, where I will have minimum capacity of that augmenting path. So the first path can be an augmenting path. The second path can be also an augmenting path. I will select a suitable path as an augmenting path where I should have the minimum capacity. And so that means, what is a path? The path is nothing but an alternating sequence of vertices and edges. Okay, where the source vertex and the end vertex, destination vertex, are different. Otherwise, it will become a cycle. So it's a path. So in source and sink. And if I write down the path corresponding to the first one, it will be like S, comma, then S to A, then or we can say like this, we can understand it. S, then A, then it is C, and then it is T. So this denotes a path. Another path is S, comma, A, comma, C, comma, B, comma, D, comma, E, comma, T. Am I correct?
Yes sir.
ইয়েস স্যার
Wrong. Now along this path, the first one, the edges are S to A, then A to C, and then C to D, C to T. And what are the capacities of all the edges? Let's consider the first one. Okay, so let's consider the first one. You can do the next. So the set of capacities, let's say capital C1, it is the capacity of the first edge, that is C of S comma A, that is 3. Then capacity of A to C edge, that is also 3. And then capacity of edge C to T, and its capacity is 1. So this is the set of capacities along that path. And out of which you have to select, or you have to obtain, the minimum capacity of an edge along that path, and which is 1, this one. And the minimum capacity along that path is denoted by a notation delta. Delta, let's say this is path P1, this is the path P1. So delta P1 will be equal to 1. What is delta P1? It is the minimum capacity along a path P1. Okay, so delta P1 equal to 1. Similarly, if you try to find out the minimum capacity along the other path P2, which is S, A, C, B, D, E, and T, here you can find that 3, 3, 1, 4, 2, 3, you can find, and out of which you can also find
স্যার ওয়ানই হবে।
delta P2 is equal to 1. So you can select P1 as the augmenting path or P2 as the augmenting path. But let's select P1 as the augmenting path and move on. Okay, because one difference can be there that P1 is having 3 edges where path 2 is longer as compared to P1. Okay, so that is the thing. So selecting P1 as the augmenting path, it is called augmenting path because this augmenting, because it is this path is chosen to serve a purpose, and the purpose of this path is supposed to increase the flow from source to sink. So it is like augmenting the flow from source to sink. It is improvising, enhancing the flow, increasing the flow, augmenting the flow from source to sink. That's why it is known as augmenting path. It's a path, it's augmenting path because its purpose is to increase the flow by from the residual network. Okay, so selecting P1 as the augmenting path with its capacity, minimum capacity is delta P1 equal to 1. Augmenting path capacity is 1. Okay, so once we find delta P1 equal to 1, then what can we say? The augmenting path algorithm says that after finding the augmenting path, you can increase the flow of all the edges along that augmenting path by an amount of delta P1. Here delta P1 is equal to 1. That means you can increase the flow of all the edges by 1 along that augmenting path P1. So I will use this picture again. Hope all of you have drawn. Okay, so if you increase the flow along that augmenting path, it will become 1 by 3, increasing the flow by 1 by an amount of delta P1. Okay, here it becomes 1, and then C to T it becomes 2. Have you understood this much?
Yes, sir.
Yes.
And remaining part of the flow network as it is. This is the flow network. This is the residual network. And from the residual network, we are finding the augmenting path and its capacity, which will help us to increase the flow along that augmenting path in the flow network.
So can we increase the second path also?
Can we increase the
Path 2 right now.
you can do that, no issue. You can try with that, no issue. Okay.
হ্যাঁ স্যার, আমি বলছি যে এই মুহূর্তে দাঁড়িয়ে কি চেঞ্জ করা যাবে এই C2 যেটা ছিল সেকেন্ড পাথটা?
No, any one path you are selecting as an augmenting path. Once you are done, that's done. That's fine. We will not. If you are considering P1, you don't have to consider P2. That's it.
আচ্ছা স্যার, সেকেন্ডে যে রেসিডুয়াল নেটওয়ার্কটা আছে,
যদি এমন হতো যে P1 এ ডেল্টা P1 হচ্ছে 1 আর একটা P2 আছে যার ডেল্টা P2 হচ্ছে 2, তাহলে P1 টাকে সিলেক্ট করতে হতো অগমেন্টিং পাথ, বিকজ আই এম সাপোজ টু হ্যাভ দি মিনিমাম ক্যাপাসিটি অফ অ্যান অগমেন্টিং পাথ।
হ্যাঁ স্যার, বলছি যে রেসিডুয়াল নেটওয়ার্কে C2B একটা কানেকশন আছে, কিন্তু অ্যাকচুয়াল নেটওয়ার্কে তো সেটা নেই। তাহলে সেকেন্ড পাথটা আমরা তো সেকেন্ড পাথটা C2B তো কনসিডার করেছিলাম, তাই যদি সেকেন্ড পার্টটা কনসিডার করি তাহলে অ্যাকচুয়াল নেটওয়ার্কে কি করে ইনক্রিজ করব?
বুঝলাম না, C2B তে এটার কথা বলছো তো? C2B ফরওয়ার্ড এজ।
হ্যাঁ হ্যাঁ স্যার, রেসিডুয়ালে আছে কিন্তু অ্যাকচুয়ালি তো নেই। আপনি অ্যাকচুয়ালি ইনক্রিজ করলেন পাথ 1 এর অনুসারে।
হ্যাঁ, আমি এই পাথে ইনক্রিজ করলাম ফ্লোটা।
এবার যদি সেকেন্ড পাথে চাই তাহলে
সেকেন্ড পাথ হলে তাহলে কিন্তু ওই পাথ বরাবর তুমি ইনক্রিজ করতে প্রত্যেকটা ফ্লোকে, এখানে হতো এইভাবে ফ্লোটা ইনক্রিজ হতো।
আচ্ছা স্যার, বলছি C2B তো নেই অ্যাকচুয়াল গ্রাফে কোনো ফ্লো। কিন্তু
So-
পার্ট 2 তে আছে ওটা।
Right. Yes, that's a very good concept. So, actually increasing the flow from C to B means decreasing the flow from B to C, isn't it?
ও আচ্ছা আচ্ছা আচ্ছা, ইয়েস সেকেন্ড কনসেপ্টটা, হ্যাঁ।
Is it? It's a very good question. Thank you for pointing out. So, as the very good question, please note it down. So, I am very happy because ultimately, in the original flow network, C to B, there was no edge from C to B. But in the residual network, you can find a forward edge from C to B, and it is here it is happened for C to B, but it may happen for any other edges also present in the residual. So in the residual network, you may have this kind of situations. And in the flow network, there is not existing a forward edge, but in the residual network, there is a forward edge, and that forward edge lies in along the augmenting path selected. So you have to increase the flow along that forward edge present in the residual network but not present in the flow network. So how can we deal with that? So for a similar situation here we don't have any forward edge from C to B, only backward edge. But in the residual network, if we select the augmenting path like this, we must increase the flow from C to B. So that is that is a vector, it's a direction. So increasing flow from C to B, in other words, that is decreasing flow from B to C. So you can decrease the flow from B to C, and thereby it will become 0/5.
ইয়েস স্যার, ইয়েস।
Is it okay now? Providing delta P is equal to 1, you are decreasing the flow by an amount of 1. So it will become 0/5 along B to C, which is equivalent to increasing flow from C to B by 1. So very good question and very important concept. Anyway, so we have now constructed.
স্যার একটা জিনিস স্যার বলছিলাম যে স্যার সি টু বি যদি মানে বি টু সি যদি ডিক্রিজ করি বাই 1 মানে 0/5 হচ্ছে, তাহলে স্যার আলটিমেটলি বি টু সি স্যার 1 দিয়ে যদি ডিক্রিজ করি তো আলটিমেটলি স্যার সি টু বি টু 5/5ই হচ্ছে না, মানে স্যার রেসিডুয়াল নেটওয়ার্কে +1 করা আর -1 করা তো একই হলো তাহলে।
রেসিডুয়াল নেটওয়ার্কে আরেকবার এটা 0/5 করলাম, তারপরে কি বলছো?
আর স্যার সি টু বি রেসিডুয়াল নেটওয়ার্কে যদি 5 করি তাহলে তো সেমই হচ্ছে না সি টু বি।
C to B, C to B 5 কোথায় আছে? 1 আছে তো।
আচ্ছা স্যার বি টু সি, সরি বি টু সি। আর উল্টো দিকে যদি আমি মানে স্যার বলতে চাইছি যে রেসিডুয়াল নেটওয়ার্কে
স্যার মানে বলছে ফরওয়ার্ডটাতে 5ই থাকবে আর ব্যাকওয়ার্ডে 0 হচ্ছে, মানে ব্যাকওয়ার্ডটা হচ্ছেই না বেসিক্যালি, খালি ফরওয়ার্ডটাই হচ্ছে।
এরপরে যখন তুমি রেসিডুয়াল নেটওয়ার্কটা কনস্ট্রাক্ট করবে 0/5 দিয়ে, তখন আর পাবে না, তখন তুমি শুধু ফরওয়ার্ড এজটাই পাবে, মানে এদিকে ফরওয়ার্ড এজটা পাবে, এদিকে এজটা পাবে।
ইয়েস স্যার, ওটাই।
তাহলে এদিকে যদি 5 পেয়ে যাও, এদিকে যদি কিছু না পাও, তখন কি হলো? এখানে একটা চান্স ছিল যে তুমি এস থেকে সি থেকে বি তে আসতে পারতে, কিন্তু যখনই তোমার ওই 0/5 হয়ে গেল, তখন শুধু এই বি থেকে সি ব্যাকওয়ার্ড এজটা রয়েছে কিন্তু কোনো ফরওয়ার্ড এজ নেই। তখন সেই রেসিডুয়াল নেটওয়ার্কে you will not able to find any augmenting path through C to B. That option will be stopped, will be not available. এখন তোমার কাছে অপশন আছে ফরওয়ার্ড পাথ এজ আছে বলে, এর পরে রেসিডুয়াল নেটওয়ার্কটা কনস্ট্রাক্ট করলে তোমার কাছে সেই অপশনটা থাকবে না। That is true. Anyway, so this is done. This is the modified version of the flow network with increased flow. So now if you calculate the flow of this overall network and tell me what is the flow of this network.
2 sir.
2. Earlierly in the original network, what was the flow?
1.
Now it is 2. So it is increased. It is augmented. So that means we are able to little bit increase the flow of the network. That is the thing. Okay. And already we have started the illustration of the augmenting path algorithm. This is the augmenting path algorithm. Introducing an augmenting path, and along the augmenting path, we are increasing the flow by an amount of the capacity of that augmenting path. Okay. Now again, reiterate this process. This is the first iteration. Now, the next iteration, you again find the residual network of this modified flow network. So please draw the residual network and tell me what will be the answer. Okay, so in the diagram, please try to use different colors for forward edge and backward edge. Usually backward edge लोग के red color देवे, forward edge लोग के green color देवे, to signify that along the green edges you can propagate from source to sink, but in the red color edges you can't propagate. You can't forward propagate from source to sink. ঠিক আছে, মিলেছে তোমাদের রেসিডুয়াল নেটওয়ার্কের সাথে? This is GF.
Yes, sir.
GF1 corresponding to this G1 modified flow network. And can you find any augmenting path over here from source to sink? Can you find?
No, sir.
Yes, because you can go to S to A and then A to C, but you are unable to go to C to D.
স্যার একটা পাথ আছে
স্যার সি থেকে বি হয়ে যাওয়া যায়।
সি থেকে বি।
তাহলে তো S থেকে A থেকে C থেকে B থেকে D থেকে E থেকে T. That is the only augmenting path available. Only path available, and that has to be the augmenting path. Okay, so is it visible to all of you?
Yes,
বোঝা যাচ্ছে? তাহলে এটার ক্যাপাসিটি কত? ডেল্টা অফ দিস পাথ, অগমেন্টিং পাথ কত হবে?
So
So
one.
1. So you can increase the flow along that augmenting path, and by increasing the flow, what you can find? এটা বাড়ালে এটাও চেঞ্জ হচ্ছে, এটাও চেঞ্জ হচ্ছে। এক ছিল, 2 হলো, এটা এক ছিল না, 2 হলো, এটা 0 হয়ে গেল, এক হলো। So this is the modified flow network after second iteration. Okay, and now what is the flow of this G2? কত হবে?
3, sir.
Yes. তো সবার আগে এক ছিল, তারপর 2 হলো, এখন 3। ঠিক আছে? Now again reconstruct the residual network. This is the iteration. Reconstruct the residual network of this modified flow network. You will continue this iteration until you can't find any augmenting path. Is this correct? ঠিক আছে?
Yes, sir. Yes.
Fine. So this is the residual network. So can you now find any augmenting path over here? This is the third
No,
iteration.
sir.
No, sir.
S to A,
না স্যার এবার পাওয়া যাবে না।
A to C, but no possibility from C to D. Then S to A to C, and then C to B. No, that's not possible. So this is the final. Here we want to stop our iteration. We are unable to find any further augmenting path. And stopping the algorithm. And what is the increased enhanced flow? That is the 3. In the original network it was 1. It has become 3. So this is the modified flow network where we have maximized the flow from source to sink. So this is the augmenting path algorithm or Ford-Parkinson algorithm, and solving the maximization problem, that is maximizing the flow from source to sink. Okay, let's go along. So now try out the algorithm on the example network, which we have discussed yesterday. And if you apply that algorithm onto that example network we discussed yesterday, you can't find any augmenting path with it. Can you find?
No, sir.
কেন? Because S থেকে A, S থেকে B কোনটাই হচ্ছে না। Okay. Now coming to another algorithm, popular algorithm, which is max flow, min cut.
স্যার বলছি একটু আগের অ্যালগোরিদম নামটা বলবেন?
Ford-Parkinson algorithm. Ford-Parkinson or augmenting path. Okay.
ওকে স্যার।
So here we have already understood the meaning of max flow. Flow is maximized from source to sink, but there is equivalently a consequence happening, which is minimum cut. And we know what is a cut and what is a minimum cut. The cut is supposed to partition a graph into two subgraphs which are disjoint, and minimum cut is that cut which has minimum cost. Okay, so can we find, okay, okay, let's take an example. আগের এক্সাম্পলটাই, okay, so the same example. Now here we can find a cut to partition this graph into two subgraphs. Partition can be like this one. Let's say we want a subgraph of which vertex set, okay, S is, let's say, small s, A and C. So S bar or S complement will be the remaining vertices B, D, E and T. So if I want to partition this graph into two subgraphs such that one subgraph has the vertex set S, A, C, and the other has the vertex set B, D, E, T. These two has to be disjoint. Then only it is a meaningful cut. So if I have to have this, so I can introduce a cut like this, isn't it? right? Is it correct?
Yes,
স্যার
sir.
এই সেট একটা বলবেন সেটটা,
Huh?
সেই ডেল্টা সেটটা ওটা?
For example, we want to partition the graph into two subgraphs. The two subgraphs means some set of vertices are present in the one subgraph and the remaining vertices are present in the other subgraph. So let's take an example that one subgraph does have the vertices A, S, A, C. So this is the vertex set of that one subgraph, and this is the vertex set of the other subgraph. Of course,
সেটা র্যান্ডমলি নেওয়া তো?
এটা randomly একটা example নিচ্ছি যাতে কার্ডটা বোঝানো
ওকে
যায়। Okay, so then this is the card which is producing this S and S bar. The question is this correct? Do you agree with this?
ইয়েস স্যার।
Yes, sir.
Okay, so you agree with this. So then mathematically, how do we represent a card? It is S comma S bar within third bracket. This is the representation of a cut. Third bracket or first bracket. So that means it is a set of pairs U comma V such that U belongs to S, V belongs to S bar. Okay, that's it. So you take one vertex from S and another vertex from S bar and form a pair. This is nothing but an edge. Correct? So this cut is nothing but a set of edges. So in this example, now tell me what are the edges which will be present in this cut?
A, comma B.
Yes,
A,
S comma B, and then
বি কমা সি,
B comma C,
সি কমা টি।
then C comma T. Okay, and these are all ordered pairs because it's a weighted graph. Direction matters, right? So S, you can verify this thing definition from here. S belongs to capital S, B belongs to S bar, B belongs to, so there is a problem. It is creating a problem, isn't it? It has to be an ordered pair. The first vertex in a pair must belong to S, but in this case B belongs to S bar and C belongs to S. So this is not a correct representation. What should it be? It should be C comma B. C belongs to S, B belongs to S bar, and then C belongs to S, T belongs to S bar. That's fine. And these are the only three edges present in the cut. Okay, sometimes we call it as ST cut. Okay, because S denotes a vertex in capital S and T denotes a vertex in S bar. Now let's calculate the capacity of this cut, ST cut. The capacity of this ST card is denoted by C of capital S comma S bar, the summation of all the capacities of the edges where UV belongs to the cut. Or in other words, it means that U belongs to S, V belongs to S bar. Correct? So you sum up all the capacities of the edges.
Four.
Okay. Now it is equal to the capacity of S comma B plus capacity of B comma C plus capacity of C comma T.
তো সেকেন্ডেরটা সি কমা বি হবে না ক্যাপাসিটি?
Yes, we know that. Okay. Okay. So okay. In two ways we can define that. Let me okay, C comma B, no issue. The capacity of S comma B, 1, 2. The capacity of C comma T, let me double check it. It is supposed to be S comma B equal to 2 and it is 2. So it also 1, it also 1. Actually here the definition is given as CUV, but it is actually supposed to add up the flows. Okay, so I will double check it. So here the capacity of the edges in a card are actually the flow amounts 1. Okay, so as per that C of S comma B will be 1, not 2. So again I will double check it. Okay, so that we don't have any confusion. So this is 1 and this is 2. And interesting fact is the C comma B. So we don't have any edge from C to B. So the value of this edge, I mean the value of flow along that edge C to B is actually 0. No such edge exists in the graph. So its amount of flow is actually 0. I will again double check about the capacity definition. It is actually supposed to add up the flows. Okay.
আচ্ছা স্যার এই কেসে আমরা তো রেসিডুয়াল নেটওয়ার্কটাকে আর ইয়ে করছি না তাই তো কনসিডার করছি
No.
অনলি যে গ্রাফটা
Flow network.
ওকে
So thereby we found that the capacity of the overall cut, this is the capacity of the cut, that is the sum of all edge capacities. And I will double check again the edge capacities definition, and is supposed the definition is actually the flow values of the edges. Okay. Anyway, because that is the definition of the cart actually, cart and cart capacity, cart based edge capacity. Okay, so there is a slight difference between the edge capacity which we have understood in the flow network and in the cart. So so adding up the flows of all the edges, and there is no such edge, so its contribution is 0. So ultimately 3. The cart of the capacity is cap capacity is 3. So this is the cart capacity. Okay. Now the question is, we are supposed to find, we aim to find a minimum cart. There may be several carts available in a flow network, but we want to find out that cart of which cart capacity is minimum. This value is minimum. That is our goal. Okay. So in this regard, we want to discuss about the theorem which is known as Max-Flow-Minkart theorem. And to start with that, let us discuss about a lemma. Is it visible to all of you?
Yes, sir.
Yes.
Okay. Okay. So let F be a flow of a flow network G. Okay. So we know that what is the meaning of flow? A G with source S and sink T. We know that this is the flow of the graph G, right? Okay, that is the flow. Okay, now let S comma S bar be a cart in G. Okay, and it's a ST cart. A vertex S belongs to S, vertex T belongs to S bar. ST cart. So then the lemma says the net flow across S comma S bar is equal to S comma S bar, which is represented by this, the net flow across S comma S bar. Okay, and that is equal to mod FG. And this is the lemma. Though these two are different concepts. The mod FG you are finding from the given flow network. And this is the net outgoing flow from this source and equal to the net incoming flow to the sink. That is mod of FG. But F of S comma S bar is the flow along the cart. The net flow across the cart. This is something which we have not computed yet. Okay, what is the flow across the cart? And this lemma says a flow across a cart S comma S bar is actually equal to the flow of the network. So in that given example which we are discussing today, the flow network has a flow of 2, যেটা আমরা আজকে একটু আগে যে গ্রাফটা আঁকলাম, যেটা কার্টটা বোঝাতে গিয়ে যেটা করলাম, দেখো S থেকে A তে 1/3 আছে, S থেকে B তে 1/1 আছে। So net outgoing flow is 2. বা C থেকে T তে দেখো 2/2 আছে, E থেকে T তে দেখো 0/3 আছে। So net incoming flow to sink is 2. That means as per the lemma, that example graph which we discussed for the cart, for lemma it is actually 2. F of G equal to 2, and also flow across that cart is equal to 2. A very powerful lemma. And it is provable. We can derive this, we can prove this lemma. we are not discussing today. লিখেছো এটা?
ইয়েস
Yes.
স্যার বলছি
বলো।
ফ্লো অ্যাক্রস দি কার্ডটা তো
3 আছে।
3 আছে।
That is capacity of the cart. Cart
তা আপনি
capacity.
তো ফ্লোটা কনসিডার করলে বললেন না যে ওটা
Cart
করতে হবে।
capacity, that is the 3 value is the cart capacity, and this is the flow across the cart. Those two are different. Okay, that is the cart capacity. One is the flow of a network, and then it's a capacity of a cart, and now it's a flow across a cart. Next we have another lemma. If time permits, I will show you the proof, very interesting proof, and all of us can understand and we can actually prove the lemmas. We can do that. Okay, but let's not discuss today, some other time. So let F be a flow of a network G. Okay, with again same definition with S and T, source and sink, and S comma S bar be a cut. In fact, ST cut, we understand what is a ST cut. S is a vertex belong to S, and T is a vertex belongs to S. Okay, so then this lemma says another very powerful information, and that is the flow of the network F of G has to be the cart capacity of S is comma S. The flow of the network is less than or equal to the cart capacity. Okay, again very easily we can prove it. Okay, just little bit, if we think we can prove this, we can do that. We will talk about this or prove this some other day. So far we have introduced ourselves with F of S comma S bar, F of G, sorry not comma, and C of S comma S bar. But that's fine. Eventually it's good, it's correct. This is as per the lemma. So these 3 terms we are familiarized today. Okay, লিখেছো সবাই?
ইয়েস।
Okay, now coming to Max-Flow mean cut theorem after understanding lemma 1 and lemma 2. And in the Max-Flow mean cut theorem is actually based on lemma 1, lemma 2 and lemma 3. Lemma 3 is the ultimate algorithm, ultimate theorem. But to come up to the conclusion to the theorem, you have to consider the lemma 1 and lemma 2. So all these 3 lemmas altogether form the entire Max-Flow mean cut theorem. Okay. So lemma 3 is let F be a flow in a network G, again with same definition, source and sink, S and T, and S comma S bar be a cut. In fact, ST cut. S belongs to S, T belongs to S bar. So this lemma says then, if it happens that the flow of the network G, see, as per the lemma 2, we have understood that F of G is less than or equal to C of S comma S bar, right? So we have two possibilities. Either the flow can be strictly less than C of S comma S bar, or f of g can be exactly equal to the C of S comma S bar. We have two possibilities. Correct? But if this possibility happens, if this happens, f of g equal to C of S comma S bar. So if fg becomes equal to C of S comma S bar, then this lemma 3 says that f is the maximum flow. Okay, and S comma S bar is the minimum cut. This is the lemma 3. Again, we can prove all these lemmas. We are not talking today about the proof. We will do some other class, but this is the ultimate. So if that happens, that flow in any network can be less than or equal to the capacity of any cart, but in boundary situation, it happens that the flow of the network becomes equal to the cart capacity. You can calculate capacity of a cart. I have shown you one example how to calculate capacity cut, right? And also how to calculate flow of a network, right? So both these things you can compute for a given flow network. For all possible cuts, you can do that. You can compute both of these, and then you can come up to a situation if this happens that the flow of the network becomes equal to the cart capacity corresponding to a cart, then that cart will be the minimum cart, and this flow will be the maximum flow. So this theorem actually gives us information or gives us a way how to find the minimum cart. So given a flow network, okay, which we have just seen, the যে এক্সাম্পলটা তোমাদেরকে দেখালাম কাট বোঝানোর জন্য, সেম এক্সাম্পলটাকে তোমরা এবার কনসিডার করো। ওখানে তোমরা যত রকমের কাট পসিবিলিটিস আছে লিস্ট আউট করো। So list out all the possible cuts and find their capacities. Make a table for list up all the possible cuts along with their cut capacities, and then find the maximum flow of the flow network. How can you find the maximum flow? You can apply the concept of residual network and augmenting part. Okay, so then you select that cut out of the list, from the list, which capacity equals to the maximum flow, Fg. So this is the process which this theorem gives us, a way to find out a minimum cut. And once you can
Fg টা maximum flow হতে হবে না?
Yes, Fg the maximum flow. That's why the theorem is called max flow mean cut. So two phenomena is achieved using this theorem. The flow is getting maximized from source to sink. It is solving the maximization problem, maximizing the flow from source to sink. Simultaneously, it is able to solve the minimization problem, that is the minimizing the cart from separating the graph into two subgraphs. Okay.
Yes, sir.
Okay.
আচ্ছা স্যার, একটা কোয়েশ্চেন স্যার, এই কাট যখন করা হয় তখন এস আর এস বার দুটো সেট নেওয়া হয়, তাহলে এই দুটো সেটের মধ্যে যে কোনো একটা সেটে কি মিনিমাম একটা থাকতেই হবে তো, একটা ভার্টেক্স?
No, you will not actually. If S becomes 5, S bar becomes actually capital V.
না স্যার, তাহলে তো দুটো স্যার, মানে ফাই নিয়ে আর কি
If
বলছি।
S becomes 5, then S bar becomes capital V. V is G is equal to V comma U. That V. What will happen? You are not actually doing cut.
ওটা অ্যাকচুয়াল গ্রাফটা।
গ্রাফটা দেখছি, ওটা গ্রাফ কাট করা।
হ্যাঁ স্যার, যদি একটা ভার্টেক্স থাকে, ধরুন ফাই আর টি থাকলো, তাহলে হয় হবে তো?
হ্যাঁ, তুমি একটা ভার্টেক্স নিয়ে করতে পারো কাট।
হ্যাঁ হ্যাঁ স্যার, ওটাই।
Okay, so I hope it's 150. We should stop here. If any further query, you can ask. I will give some problems to for practice. It will be helpful for you. But yes,
আচ্ছা
I'm
স্যার, যখন
again.
মড এফজিটা
হ্যাঁ,
যখন মড এফজিটা স্যার লেস দেন সি অফ এস কমা এস বার হচ্ছে, তখন স্যার জাস্ট খালি মানে নর্মাল ফ্লোটা আমরা পাচ্ছি, তাই তো? মানে নর্মাল ফ্লো আর মানে কাটটা মানে নট মিনিমাম, তাই তো?
কাটটা না মিনিমাম, রাইট।
আচ্ছা
ফ্লো যেভাবে তুমি পাচ্ছ ম্যাক্সিমাম ফ্লো তুমি ধরো ওই ইয়ে থেকে একটা উদাহরণ দিলাম যেটা ফোর্ট ফারকালসন অ্যালগরিদম দিয়ে তুমি ম্যাক্সিমাম ফ্লোটা পাচ্ছ। তো ইউ ক্যান ক্যালকুলেট দ্য ম্যাক্সিমাম ফ্লো, ঠিক আছে? এবার সেখান থেকে তুমি
আচ্ছা।
এবার একটা কাট সিলেক্ট করে নিলে যে কোন কাটটা মিনিমাম কাট হচ্ছে ফ্রম দিস।
স্যার এই থিওরেমের জন্য ম্যাক্সিমাম ফ্লোটা তো প্রিরিকুইজিট একটা।
ইয়েস, দ্যাট ডিপেন্ডস অন দি প্রবলেম। ওকে, তো এমন প্রবলেম দেওয়া হলো যে যেখানে বলতে পারো যে হয়তো আমরা ম্যাক্স ফ্লোটা বের করে নিতে পারবো, ম্যাক্সিমাম ফ্লোটা ধরো আমরা বের করে নিতে পারবো। It depends on the problem.
আচ্ছা, আচ্ছা।
Yes, for simplicity, for as a beginner, we can understand that the maximum flow will be a prerequisite. We have to find out the maximum flow by some algorithm. Let's say augmenting path algorithm. Okay.
তাহলে তো শুধু এই থিওরেম দিয়ে মিনিমাম কাটটাই বার করতে হবে।
মিনিমাম কাটটা বের করছি, and this এই কাটটা দিয়ে শুধু মিনিমাম কাট বের করছি শুধু তা নয়, মিনিমাম কাট বের করছি ইউজিং দ্য ম্যাক্স ফ্লো আইডিয়া, এবং একটা কনক্লুশনে আসছি যে যদি ম্যাক্স ফ্লো হয়ে যায় তাহলে মিনিমাম কাট হবেই, মিনিমাম কাট হলে ম্যাক্সিমাম ফ্লো হবেই। দ্যাট ইজ দ্য থিং।
হ্যাঁ হ্যাঁ হ্যাঁ।
এই থিওরেমটা ওটা বলছে, মানে শুধু বলছে না যে মিনিমাম কাট, এটা বলছে কিন্তু ম্যাক্স ফ্লো দুটোই হবে, ম্যাক্স ফ্লো হলে মিনিমাম কাট হবে, ঠিক আছে? তো এবারে কেস হচ্ছে যে ধরো ওই যে আমরা যে ইমেজ সেগমেন্টেশনের প্রবলেমটা যেটা আমরা যদি আজকে ভালো হলো না কনসিডার করেছিলাম, ওই সেগমেন্টেশন প্রবলেমটাতে আমরা একটা মিনিমাম স্প্যানিং ট্রি বের করেছি, মানে একটা গ্রাফ বের করেছি, ডিরেক্টেড গ্রাফ। এবার হচ্ছে মিনিমাম স্প্যানিং ট্রি থেকে আমাকে পার্টিশন করতে হবে, তাহলে একটা কার্ট ইন্ট্রোডিউস করতে হবে, যেটা আজকে আমরা দেখলাম একটা কার্ট ইন্ট্রোডিউস করা। সেই কার্টটাকে এমন ভাবে ইন্ট্রোডিউস করতে হবে, আমি বললাম না অপটিমাল কার্ট ইন্ট্রোডিউস করতে হবে, তাহলে কি মিনিমাম কার্ট ইন্ট্রোডিউস করতে হবে। মিনিমাম কার্ট কি করে বের করবো? এইভাবে বের করতে পারো, দিস ইজ ওয়ান ওয়ে। ম্যাক্স ফ্লো মিন কাট
ম্যাক্সিমাম ফ্লো ইয়ে করে।
ইয়েস, রাইট।
আচ্ছা
সো ম্যাক্স ফ্লো মিন কাট থিওরেম দিয়ে তুমি মিনিমাম কাটটা বের করে নিলে, মিনিমাম কাট যেই বের করবে তুমি সাব অপটিমাল সাবট্রিজ পেয়ে যাবে। সাব অপটিমাল সাবট্রিজ পেয়ে যাবে মানে সাব অপটিমাল কেন কথাটা বলছি, প্রত্যেকটা সাবট্রিজে ফ্লোটা ম্যাক্সিমাম হয়ে যাবে অটোমেটিক্যালি, right? So that is the thing. So what should be the partitioning algorithm in that image segmentation problem? So if we use max flow min cut theorem, so the subtrees after partitioning will be optimal in terms of the maximum flow, okay, and also the cut will be minimum. So এটা কি এই কথাটা আমি একটু বলছি যে একটু উল্লেখ করতে পারো আর কি, যদি সম্ভব হয়, ঠিক আছে? তাহলে কমপ্লিট হয়ে যাবে সেগমেন্টেশনটা।
ওকে স্যার।
আচ্ছা, ওকে, থ্যাংক ইউ। আমি অ্যাটেন্ডেন্সটা নিয়ে নিই।